have another problem. We're still working in Finney on page 489. We're going to take the work that we did prior and apply it to find a power series. So we can kind of see how everything comes full circle now. So problem 27 wants us to work based off exercise 21, which you already worked in the previous video. So we're working with the summation where n equals 0 all the way up to infinity of 2 to the n x to the n. Well, based off exercise 21, we already know that we have a function f of x equals 1 over 1 minus 2x for our interval negative 1/2 x 1/2. That's our interval of convergence. These are things that we already know. So we want to take that and we want to find a power series for f prime x. This is the good stuff. So we know what a power series looks like. So we're saying, okay, well, what did they plug in? They plugged in 2x for the r. So we're going to say, okay, well, that's 1 over 1 minus 2x. And we're going to substitute that in for all our values for the power series. We're going to say 1 plus 2x plus 2x squared plus 2x to the third plus dot, 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 dot. We know this goes on forever. Do we remember this? If we don't, please ask questions or go back, check your notes. So we want to take this and remember, we want to make a power series for f prime of x because right now we already have the power series for f of x. So we're going to say d dx of 1 over 1 minus 2x of d dx of this power series. So 1 plus 2x plus, what is that, 4x squared plus 8x cubed. I'm going to change my screen so this looks a little bit nicer. So plus 8x cubed plus dot, 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 dot. And we can see the pattern that's going on. What is it? It's 2 to the n, x to the n. And then again, we just keep going. All right, well, let's take the derivative of the left-hand side. All right, well, 1 over 1 minus 2x, we can re-represent that as 1 minus 2 to the x to the negative 1. Well, we know how to take the derivative of that. So that's going to be negative 1, 1 minus 2x. Take the derivative of the inside, which is negative 2. But let's not forget that that's still a negative 2 for the exponent because we're subtracting off of 1. Simplify that out. That's 2 over 1 minus 2x to the second power equals, okay, well, we got to take the derivative of this thing. Well, the derivative of 1 is nothing. So then we get 2 plus 8x plus 24x squared. Okay, what pattern do we have going on here? Plus dot, 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 plus, oh, that's 2 to the n times n times x to the n minus 1 plus dot, 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 dot. We can keep going. We can find an infinite amount of terms. So we can rewrite this power series and say, wait a second, we just found a polynomial that works for this f prime of x. So f prime of x equals 2 over 1 minus 2x, my 1 didn't write, equals the summation of n equals 1. Think about, wait a second, why is n equal to 1 rather than 0? Go back here. So that's all the way up to infinity of 2 to the n times x to the n minus 1. And our interval of convergence is still negative 1/2 to 1/2. And you all just created a power series for f prime of x. Congrats.